open your books to page 359, we are going to start lesson 24-2, which is adding polynomials. And we're actually going to skip this first learning target that says use algebra tiles because virtual students don't have algebra tiles and I don't want to hand those out to face-to-face students because of COVID. So we are only going to focus on adding polynomials algebraically. So what I want us to do first is go to page 361 where you see question 4 talking about like terms. Earlier this year we talked about like terms when we were adding and subtracting for solving equations and solving inequalities. So like terms, if you remember, are terms that have the same variable. So x and x, or w and w, and they have to have the same exponent on the variable. So if I have x squared, I also would have to have another x squared for them to be like terms. Okay, and all constants, remember constants are numbers by themselves, all constants are like terms. So for question 4, it says state whether the terms are like or unlike and explain. So if I'm looking at the first one, remember they have to have the same variable, so they both have x's, but they have to have the same exponent. So these are unlike terms. We cannot combine them or put them together because they have different exponents. Okay, so I want you to go through B, C, D, and E and say unlike or like. So pause the video and take the time to answer these questions. B, these terms are unlike terms, so we cannot combine them or put them together. Why? Because one has a variable x and one does not. So this 5 is just a constant term. We cannot combine them or put them together. C, these are like terms. Same variable of y's and same exponent of 1. So we could combine these and put them together. Letter D, these are unlike terms. Yes, they both have x's and y's, but notice they have different exponents. This x is squared, the next one has a 1, this y has a 1, the next one is squared. So these are unlike because of the exponents. Letter E, these are like terms. Why? Because they're both constants. They're just numbers, so we can always put numbers together. So these are like because they're both constant terms. So what we're going to do now is we're going to go back to page 360. Towards the bottom, you're going to see try these A. And again, we're just going to add these using algebra or using the algebraic method instead of using algebra tiles. Okay, so it's actually going to be a little bit faster and a little bit easier. So what we're going to do for letter A is we are going to combine or add our like terms. So x's go with x's, constants go with constants. So we're going to add the coefficients out in front. So 1x plus 2x is 3x. And then let's add or combine the numbers. -2 plus 5 is a positive 3. And that's our answer, 3x plus 3. Okay, I'm going to do one more with you, and then you're going to try it by yourself. So I'm going to add the like terms together. And if you need to, find highlighters, or you can circle, you can underline, you can box, so you know what your like terms are. So I have 2 plus 3, which gives me 5y squared. Then I have a plus 3y. I cannot combine that with anything. And 6 minus 4 is positive 2. Okay, I want you to pause the video, and I want you to do questions C and D on your own. Okay, let's do our x squareds first. So 2 minus 1 is just 1x squared. 3x minus 4x is negative 1x. 9 plus a negative 6, 9 minus 6 is 3. That's my answer. And these last ones are not written in standard form. Okay, so make sure you're combining the correct like terms. So I have a positive 1x minus 3x squared. So that's negative 2x squared. Then I have a negative 3x plus 2x. So that gives me negative 1x. And then I have a positive 5 and a positive 4. 5 plus 4 is 9. And make sure your answer is written like this, because in lesson 24-1, we learned what standard form is. Now, if you did the constants first, and then you had your x, and then you had your x squared, then go ahead and rearrange it. So take it and convert it to standard form. Okay, now we're going to jump to page 362. We're skipping the examples because we already know how to do them. And we're going to page 362 where it says try these B. Notice the directions. You're going to add these polynomials together and then make sure you're writing your answers in standard form. If you don't remember what standard form is, take out your note sheet. But I want you to pause the video and I want you to try to do A, B, and C first on your own before I go through the answers. You can do it. I'm going to work in order of standard form so I don't have to convert them at the end. So I'm going to look for the highest exponent. So I have 4x squared plus 1x squared. Then I'm going to look for my x's. And there's only one of them, so minus 3x. Then I'm going to look for my constant terms, so positive 3 plus 5 gives me 8. That's my final answer. Again, I'm going to look for or start with the highest exponents. So 10 plus 17. Then I just have a y, so plus 8y. And then my constant terms, 6 minus 11. And both of these are in standard form because they're in descending order. The largest exponent first, constant term at the end. Letter C. Let's work with our x squareds first, so 9 minus 13. Then I'm going to work with my x's, so 15 minus 11. And my constants, positive 21 minus 26 is negative 5. So this is the last question we're going to cover in the book. So now I want you to work on lesson 24 to practice. You can turn it in virtually on Schoology, or you can hand in the paper to the bin.